Again, my name is Georgie from Midwest Optical Systems. We're located right outside Chicago, Illinois. It's good to be here with all of you. I'm here to talk to you today a little bit about optical filters and how they can help to elevate and protect your system. So one thing that we want to get off the bat, off to a good start and say is that filters are an absolute necessity and not just an accessory. That's something that we believe at Midwest Optical Systems. We believe that if you're working on any kind of vision application, you're going to need some kind of filter for that application to perform really well. What is a filter? Well, if you're here, you probably have some idea what an optical filter is. It's simply a component that helps to pass certain wavelengths and block other wavelengths. So if in your application you're looking at a specific wavelength or a specific color and you don't want to see anything else, a filter does a great job of blocking those unwanted wavelengths and helping to pass those wavelengths that you are interested in looking at. Filters help with lots of different things. They help to increase contrast, reduce glare, help to correct color, increase resolution, and we're going to look at a few different applications and reasons why you would want to use a filter. Filters are used in every industry, whether they be intelligent traffic solutions or factory automation, robotics. Anytime, again, you want your system to be looking at something specific, a filter is going to help you achieve that. So, one of the best things that filters help to do, specifically bandpass filters, that I'm going to show you in just a moment, they help to increase contrast. Contrast just means you're creating some kind of separation so that your system has an easier time of picking one thing out from another. So maybe you're trying to read a barcode or a certain color or a date code. Filters help to increase that contrast. Here's a simple example of how a red bandpass filter or a blue bandpass filter can help to increase and create that contrast in a grayscale monochrome image. If you're working in an application like 3D metrology, we're using a blue laser. The only thing that the sensor cares about or wants to see is that particular blue wavelength. And in situations where there's lots of different ambient lights or reflections, and the sensor is having a hard time seeing that blue laser, you can use a filter to help increase that contrast. We also call filters a very inexpensive insurance policy. Oftentimes, you're designing an application in a room that looks like that first image. Lighting conditions are ideal, everything is working properly, but then what happens? You move the application to something that looks like that second image, a customer site, and all of a sudden the application is not working well anymore. And so what are the solutions? Well, one, you can create a big shroud that goes around your entire system to block all that ambient light. That's going to cost a lot more money, take up a lot more space. Or you can try turning off the lights, but the people who are working in that location probably is not going to appreciate that. But if you'd use a filter which controls the ambient light and only is passing the light that you are intending to use, you're essentially shrouding the system. And so contrast, ensuring repeatability, these are a couple of things that filters help to do really well. So, sometimes you're in a situation where glare might be an issue. You're inspecting something that's shiny or reflective, and glare is causing some read issues for your system. Now, polarizing filters are a very good solution to help reduce that specular glare. Polarizing filters work in tandem with both the filter on your lens and then film on your light source. Using these together helps to reduce that glare very well. Here's an example of an application. You can see in that first image, there's a lot of glare. It's very difficult to see. But using polarizing filter and polarizing film in the third image helps me to reduce that glare pretty drastically and allows for a clear image read. In the last image, I'm using a red bandpass filter just to get rid of some of that ambient light to, again, just increase that contrast. So if you're ever on an issue with glare, then polarizing filters are very useful. Neutral density filters are very essential if you're dealing with too much light. If you're working in an outdoor application, or if it's an indoor application and there's too much ambient light, neutral density filters are like sunglasses for your system. They help to reduce the amount of transmission or light so that you're able to see the subject properly. This is the same material that's put in welding masks. So if you're working on an application where there's a lot of blooming, this is a great filter to use to, again, bring down that transmission. You can stack neutral density filters to help reduce that transmission. So if a certain optical density is not working, you can stack on top of that to reduce the transmission to the needed requirement. Neutral density filters come in both absorptive and reflective, depending on your application need. If there's a lot of high heat, you might want something that's more absorptive than reflective, but depending on your application, we have several different options that you can choose from. Multi-bandpass filters. So if you ever encounter intelligent traffic solution applications, or NDVI, where you're using a drone to inspect land and you're looking at the reflections of certain wavelengths, multi-bandpass filters are a great solution. When it comes to intelligent traffic solutions, typically these systems have one camera for the day, one camera for the night, but with the multi-bandpass filter, you can use a single camera, single lens, and these two channels allow you to pass different wavelengths. One, during the day, you can pass sunlight, and at night, when you're using an infrared illuminator, you can use the second channel. So very good for those types of applications. Again, these filters have two different channels instead of just a single one like a normal bandpass filter would. One thing that you might not be thinking of using filters for is to protect your system. And so protecting your system is very essential, especially as we're seeing more deployment of embedded systems, these small systems in very rugged environments. Protective windows can be very essential in protecting your essential components like your computer or processing unit, lenses. You can get these protection windows in multiple different substrates. So if you're in an environment, whether you're using a drone or a different aerial vehicle, or you have an application that's being used in farming, these types of protective windows come in all sorts of different substrates that can handle different elements, different temperatures, and again, they can protect your essential systems. You can apply optional coatings to these windows. Again, if you need something that's going to help prevent liquids or grease from sticking on the surface, or fingerprints, these optional coatings like a hydrophobic coating can help, or oleophobic coating can help prevent those types of issues. VHB tape, silkscreen printing, these are all things that you can do to customize your protective window so that it can look like a system that's coming from your specific organization or company. Lots of opportunity for customizability with these types of protective windows. Now, whether you're working on a simple application where you're looking at a few different colors, a color sorting application, or you're working on a next generation application like using LiDAR or NDVI, as I mentioned, metrology, or a SWIR application, filters are going to really help with those applications by blocking those unintended wavelengths and passing the ones that you'll need. Now, a common question that I get is, well, how do I know which filter to select? Sometimes you'll know right away based on the wavelengths or based on a past application, but a really easy way is to use a filter kit. Filter kits contain multiple filters that you can test with to find the exact filter that you might need for your application. So again, filters are a necessity, not just an accessory. They're very good at elevating your applications and also protecting your systems in these very rugged environments. And filter kits are a great way to test your applications. So again, my name is Georgie with Midwest Optical. We have a booth in Hall 10, F52. If you want to come by and check out our filters or need some advice on how to get going, please stop by. We're also giving away several of these kits, and we'd love to give one to you. So thank you again for your time.
Brilliant. I hope you found that useful. First, has anyone got any questions? No, so I think, going back to the first principle, when you stick a camera looking at something, you see everything. Your brain's really good at picking out the thing you want to see, but a camera's not. And having the right filter really does allow you just to highlight, that picture of the Beck's bottle is a great example. Glass, reflective, shining everywhere, ambient light, all these lights will get in the way. Right filter, suddenly you just see exactly what you want to see, makes the application easy, whereas before people have been doing lots of software algorithms to try to find that, and they don't do it. So it's a really good example. So again, having an armory of components and people you can go to have a discussion is invaluable. So thanks very much for helping us on that. That's really good. Cheers.